Hello teacher, this is our presentation about the morphology of robots. We are Avan Gonzalo and Joshua Rodriguez. First we have the anthropomorphic robot that is the same than angular and articulated robot. These robots must have 3 or more axes, the type of rotation. These robots are the most used in the manufacturing and industrial processes, and these robots normally have mounted a tool in the end of the arm that is designed to have 6 degrees of freedom. And the principal applications for these robots are to do complex operations such as welding, product assembly, and machining. The next one are Cartesian robots. These robots are made up of 3 prismatic joints. So the tool is limited to linear movement, and the Cartesian name is derived from the 3-dimensional Cartesian coordinate system, which consists of X, Y, and Z axes. The Cartesian robots are the simplest robotic systems, since their operation only involves linear movements. There are many applications for these robots. Could be the simple application like pick and place, where the robot just pick an object and then put it in another place, and can be always more complex operations like the control for 3D print or CNC machine. And
Robot's cara. Let's start with the question, what is a robot's cara? Robot's cara are extremely versatility robots that start out for working at high speed in pick and place, and expanded application numerical sector beneficial for the factory presented by the robot for the automatic industrial of the food and pharmaceutic. Robotics cara, also known as robotic arm, are a secure story in the history of the automation. It's a 4 degrees of freedom, offer much more speed, precision, and possibility that the 3-axis Cartesian manipulation traditional usage of manipulation. Next. The acronym for SCARA is Selective Compilation Assembly Robot Arming, and in Spanish is a seleccionable adaptable Assemble Robótico de Brazo. It stands in the stand of the beginner small sign robot that has been designed to perform repetitive work at high speed and with high precision. One of the type application is pick up and traveling path from point A to point B, which is the work and pick and place. Who do the work? SCARA robot arm, the signal, is much like a human arm. The first axis moves horizontally. The second axis is moved of the first axis along us to position in 2 dimensions. The third is the third axis is component of the spending that adds the vertical component. The fourth axis is the rotation of the simple spell, which also the production to the oriented in the same position on the place. Do you have complaint installing for the manteniment? Next. Do you have complex install and manteniment? This type of the robotic requirement periodic reaction of the spending and typically the battery that stores the current revolution count has to be changed with Epsom's T series and LSB Tor and innovation in core system enable battery-free operation to save manutention of the champion battery and avoiding the risk of delays. Robotic calibration is the very run out. Next. Advantage of the Epson Scar robots. They are really fast and precision robots in the work cycle. They increase the production of the processes and have a very fast return on investment. They have all capacity of up to 20 kilograms and reach up to the 1 million millimeters. Guaranteed production and quality is your production line. Specific suited for the repetition work, they have expectant repercussion of the precision. They have the best position technology, smart motion, turn technology, this control minuscule vibration in position to really the final position must be and smooth. Next. For example, hardware can see the difference between an Epson model and any other. In this graph, we see the relation of the position and time, where we can see that there was a very fast movement stabilization. Next. Robot polar. This type of the configuration is complete of the perpendicular rotation axis and one linear axis. They are Hallen spelling of the polar redound test the axis from a polar coordination system. Down the variable jump the proving the robot with the application to the movies and the R with the spell robot. Next. In rotation of the teeth space leads on the zone and has arm expansion and retraction, and each area of the special the performance of the spell. In the present some Brown where performance is simply translation movement of the loss of the precision when the one with had load at the with the arm very expanded. Next. In the application is the hormone low handling operation that do not require complex movement, machine hands, handling and the casting processes, among others. Next.
The next one is the Delta robot. This robot is the most different than the other robot that we saw. This robot normally have six axes, six spheric axes. A Delta robot consists of at least three arms connected to a tool and a common base. The tool is connected to the arms by joints, and the base is connected by three joints driven by revolutions. The tool of a Delta robot can move along all Cartesian axes and also among all the vertical axes. The result is a sphere-shaped work area. That's because it's atmospheric axis. Delta robots are suitable for quick pick and place application in pharmaceutical, food, and industrial electronics. This is an example how the Delta robot functions. As you can see in the video, there are a conveyor belt moving objects from one side to another side. But you can also see that the object that is carrying are very small and not so weight. That's because this robot can only be used in certain processes that require great speed, but that the objects are neither very large nor very heavy. To be more clear, here we have another example where you can see a line that includes different type of morphologies. Here you can see first you can see a scatter robot that is placing an object in a piece. Then the next one is an articulated robot where a camera is telling to the robot if the component that put before the scatter robot is correct, and if it doesn't, so the scatter robot fix it. The articulated robot fix it. Sorry. Then there are another scatter robot that is placing a protection for the piece that is in the current. And finally, there is a Delta robot that is baking all the components to its future transportation. So every robot is working together. Each one it's doing the work for it's better. But if we combine all of the morphologies, we can do a production line that can be automated and much more efficient, and where an operator is only supervising the work and the maintenance of the equipment. And here is where we apply the sixth robotic law that say that the robots cannot replace a human in the work. For the finish, as a conclusion, we can say that there are different types of robots. Each one can be used in different processes, but they can also be combined in different parts of a process. And at the end, even if there are differences between the robots, they must be versatile, reprogrammable, with 3 axes or more, capable of using tools, and capable of moving objects through the programmer routine. And that's it. Thanks.